Assalamualaikum, students and fellow physics enthusiasts. Today's episode is focused on finding the center of mass of a system or a composite body. May I invite you to stick around, watch, and learn. The question is, a square block, a rectangular block, and a semicircular block are arranged as shown in the figure. Given the dimensions and the relative masses, find the center of mass of the composite figure. Use the axis provided as reference for the origin, x equals 0, y equals 0. In this illustration, we have the three figures arranged as shown. Relative to the origin, x equals 0 and y equals 0, we emphasize that each side of the square is equal to L units and the mass equal to 1m. The semicircle has a diameter equal to L units with a mass of 1.67 m, and the rectangle has dimensions L over 2 by 2L units with a mass of 0.85 m. We assume each figure to have a uniform density, which means the center of mass of each is located at the geometric center. The position vector r in terms of the x and y coordinates of each figure relative to the origin may be expressed as, for the square, the position vector r1 is quantity 0.5 L, which represents the x coordinate, and 0.5 L for the y coordinate. For the rectangle, the position vector r sub 2 is quantity L and negative 0.25 L for the x and the y coordinates respectively. And for the semicircle, the position vector r3, right, is quantity 1.5 L for the x coordinate and 0.21 L for the y coordinate. The y value, 0.21 L, is obtained by using the formula of getting the y coordinate of the centroid of a semicircle. Y equals 4r over 3 pi, or 2L over 3 pi in terms of the given quantity L, right? So as shown again in our diagram, for the square, this arrow represents the vector r1. For the rectangle, the vector position vector r2 is represented by this, all right, vector arrow. And for the semicircle, r sub 3, this is the arrow that represents the position vector. Take note that that point there is what we call the centroid of a semicircle object. We'll now determine the center of mass of the composite body or the system, represented here by the position vector r sub cm. And its general formula is quantity m1 times r1, all right, where m1, of course, is the mass of one body, and r1 is the position, all right, of the body relative to the origin, plus m2 times r2, where m2 is the mass of the second body, and r2 is the position vector of body number 2 relative to the origin, plus m3 times r3, where m3 is the mass of body 3, and r3 is the position of body 3 relative to the origin. Alright, so plus whatever, depending on how many bodies there are in that system. And then the sum will be divided by the total mass, denoted by capital M. And as applied in our situation, alright, we first determine uh, the position vector, okay, for the x-coordinate. We label that here as x of cm. And that is equal to 0.5 L times the mass m. Alright? Plus, alright, or this is for the square. Then add to that, of course, is the L multiplied by 0.85 the mass m. This is for the rectangle. And then add to that 1.5 L multiplied by 1.67 m. That's for the semicircle. Alright, so after getting the sum, we will divide it by the total mass m1 plus m2 plus m3. Alright, which is 3.52 m. So doing our math, we will get the value for the x sub cm equal to 1.1 L. Likewise, for the y coordinate, y sub cm, we have 0.5 L times m, that's for the square, minus 0.25 L times 0.85 m for the rectangle, and plus 0.21 L times 1.67 m, okay, that's for the semicircle. Then again, we divide, okay, this by the total mass 3.52 m, and again doing our math, we will get the value for y sub cm equal to 0.18 L. Alright, so now that we have the x coordinate and the y coordinate, alright, of the center of mass of the system, we can now therefore answer the question raised in the problem. Alright, the center of mass of the system or the composite body relative to the origin is at x equal to 1.1 L and y equal to 0.18 L. Alright, this is the x and the y coordinates, 1.1 L and 0.18 L respectively. And that concludes our video tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.